I'm Stephen Foskett, the organizer of Tech Field Day, and you're about to see a presentation and discussion with Docker. Around the table, we have a dozen and more independent experts in enterprise IT, and they are here to listen, to discuss, and to interact during the presentation. If you'd like to learn more about this event, you can go to techfieldday.com, and if you'd like to see more videos like this, you can go to youtube.com/techfieldday.
Hey everybody, my name is Vivek Saraswat. I'm a product manager at Docker. I work on Docker Datacenter, our enterprise product. So we've got a couple of speeches lined up for you today, some presentations around different aspects of the Docker community and the Docker infrastructure. In particular, I'm going to talk to you with a little intro to what Docker is, what containers are, and Docker for the enterprise, the workflows that make up our enterprise component. First question I just want to quickly ask, how many people here have played around with containers? Okay, pretty much almost everybody. So that's good. So we'll be working through a little bit of the basics, but really the main focus is on what you can do in a production setting with Docker. So just a little quick introduction on who Docker is as a company. Our mantra is that we help people build, ship, and run distributed applications anywhere on any environment. We have a number of Docker users running in production. We ran a survey here that showed roughly 51% of Docker users surveyed in this were running in production. Among our customers, we have some pretty big names. We had ADP, payroll insurance company, come in at DockerCon and show how they were running on top of Docker Datacenter in production. So containers are here to stay for the enterprise. We built up a philosophy called containers as a service, and I'll talk more about what this means. But it's an integrated platform for IT and developers to operate an application supply chain. And we're also a commercial technical support provider, along with partnerships with folks like IBM and most recently Microsoft. We're also the primary sponsors and contributors to the Docker project, which is an open source project that helps maintain the underlying container primitives. There have been so far over 5 billion image plus downloads, I think more by the time before the slide was written, 2,500 plus thousands of contributors and hundreds of thousands of Dockerized applications. So containers are becoming a more and more important part of the development world and the IT world as a whole. And if you look a little closer, you'll see that containers and Docker are really the driving force behind a lot of the modern app initiatives in IT today. So there's three sort of major initiatives that we've seen, and Docker is a part of 3 out of these top 4: microservices, DevOps, and cloud. Microservices being the idea of moving your applications away from a monolithic structure where everything's compacted into one large application to a series of independent services that interact with each other and can be swapped out and upgraded at will. DevOps is really the idea of helping devs and IT operations folks to work together to provide a more seamless, continuous integration application supply chain. And then finally, everyone here is probably pretty familiar with the cloud, bringing applications from on-premise data center environments to different types of clouds, whether it's one of the public clouds, whether it's a private cloud environment. So containers are really making that entire process of transitioning to the cloud and adopting a hybrid cloud strategy more easily available. So what is a container? Again, it looks like most people here have played with containers, so I'll go through this quickly. But if you think about it, a container is a single isolated instance that contains the resources and file systems necessary to run typically a single application and all of its binaries, libraries, and packages. In deeper terms, a container consists of a series of layered images based on a layered file system. There's the base image, which is typically the OS packages that the container is based off of, and then a series of different images consisting of the different application packages up to and including the writable layer, which is what's created when you first actually run the container. And this today sits on top of Linux and most recently now runs natively in Windows environments. So it's extending to a number of different architectures.
Define natively in Windows environments.
So previously, you had to run a Linux VM in a Windows environment in order to run containers. As of, let's say, Windows Server 2016, which was released back in October, you can actually run Windows native containers, as in containers based on a .NET framework, for example, no Linux components required. Now that is for Windows Server 2016 very specifically, but Microsoft is expanding the capabilities to be available on multiple types of platforms.
So this will be a very, very basic question since it's Windows Server 2016 on the Linux guy. So are those containers running Windows applications inside, or are they running like Ubuntu?
They're running Windows. So you can run Linux if you run a Linux VM in Windows, but those specific applications on Windows Server 2016 are Windows native applications. And we're going to be talking more about exactly this topic actually in Michael Freese's presentation in a bit. So he'll run through the actual architecture of how it all works, if that's more helpful.
No, we don't need to hype Windows at all. Like I said, I was a Linux guy. Full disclosure up front.
Totally fair with me. I wanted to make a quick digression into containers and VMs and just mention that containers and VMs are different. A VM consists of a host or a virtualized operating system plus all the application stacks above it. A container literally is just a package around a single application that sits on top of a host OS. But they're not mutually exclusive. As the diagram here shows, you can run containers on top of an OS, on top of a VM. So on the left here, you can see this is assuming no VMs. You have your operating system, and the Docker engine is the daemon process that allows you to run containers. So you have a series of individual containers. The example on the right, you have a hypervisor, something like, say, ESX, which is running individual VMs with their own OSs. Some of those VMs have the Docker engine daemon that allows you to run containers. So there's nothing saying you can't run containers and VMs at the same time. They serve different purposes and different use cases, and they can, in fact, be complementary. So quick glossary of terms that you might hear thrown around in the next couple of presentations. So a Docker image is really the schematics of how the application should be built. The Docker image contains contains the machine-readable code of all the layers of that container, and that can be moved to a bunch of different environments. From a Docker image, the Docker container is the actual runtime instance of the application. So you can use a Docker image to create multiple Docker containers. That container only stays alive as long as it needs to for the application. So the image is more permanent, and you can create multiple versions. The container is the temporary instantiation for an application instance. The Docker engine, as we mentioned, is the underlying daemon process that sits within the host OS and is what actually creates, ships, and runs Docker containers. And that can run in a Linux environment and most recently in Microsoft. And Michael will talk more about how that actually works. The final point is Docker Datacenter. This is the product that I specifically work on, which is an integrated enterprise solution that uses all of these tools plus more for actually building and deploying and managing containerized workloads in a dev or production environment. So that's a series of tools for how you might run this in enterprise. So let's go take a step back now that we've talked a little bit about what what a container actually is, and go back to what are some of the core fundamental problems we're running into IT today. So you may recognize these folks from a nice little show called Silicon Valley that often hits a little too close to home. But let's say on the left, Dinesh represents the developer, and Guilfoyle on the right represents the IT operations person. So what are each of these personas looking for in a modern environment? Your dev is typically asking for faster, easier app development. How can I iterate more quickly, create new versions, separate those versions? How can I move faster to rapidly develop the application that I'm trying to build? That's really about agility, if you think about it. Your IT operations person is typically looking for how can I standardize and secure these applications in a production workflow? How can I manage this at scale? How can I do so in a way that's not going to break my deployment and is not going to give the wrong people access to a different environment? So, that might be really about control. And on the side, you have folks up the chain who are looking to figure out how does this work in a number of different environments, right? How do I run it on-prem? How do I run it how do I run it in the cloud? How do I run it on Linux? How do I run it on Microsoft? So they're really looking for portability. How can I make sure my workflows work across different environments? So how do you go about meeting all of these challenges? That's really where Docker's enterprise core values come in. It's those three things that I was keying off of: agility, portability, and control. So for us, agility is primarily a developer mindset. It's about extending that familiar developer experience, being able to self-service build the stuff that you need to build from whatever selected content is appropriate for that enterprise environment. And it's also giving you something that's easy to set up and use. From a portability standpoint, bridging the gap means having a consistent API that everybody understands, right? Developers understand it, IT understands it. It works across different environments, no matter what you're doing. You also need a seamless dev to prod workflow. You need something that when you move from dev to test to prod, you don't run into issues. Now, how many times have you guys had an application that starts in dev and it works fine on the dev laptop, you move it somewhere else and it breaks? That's pretty much all the time. So the goal is to build something that makes that process a little more seamless. It gives you the same primitives that work across environments. And finally, you need to work across different kinds of infrastructure. Your compute infrastructure, your networking, your storage. You've got to make sure that your core application works no matter which of those environments you put it in. Finally, with control, you're really talking about how this manages at scale. It's all well and good when it works on one laptop, 2 nodes, 3 nodes. What about 100 nodes? What about 1,000 nodes? How do you make all this work at a large scale? How do you provide end-to-end security, which David Lawrence is going to talk a little bit more about in his presentation, across all of the cluster, from dev building all the way to running in production, for both content and then setting policy to enforce these issues. And then finally, integrating with whatever existing IT systems you already have. So these are the issues around control. So I mentioned containers as a service earlier. What exactly does that mean? The top line buzzword is it's an IT ops managed and secure environment for developers to self-service build and deploy applications. So what does that actually mean in plain English? It means developers get the tools they want to build the things they need, and IT ops gets a secure, scalable environment. Again, it's agility and control, but with some amount of control of portability across the different types of infrastructure you use. That's all you're looking for. Devs get what they want, IT gets what they want. So how does this containers as a service and the Docker Data Center enterprise workflow really help with this? We kind of split it back up into that build, ship, and run categories, and it works something like this. Your developers are building are building on their laptops or their personal workstations. They're going to pull some sort of base image, which is blessed by the IT folks. That could just be the base OS they work off of. It could be the programming stacks that are used, such as the types of programming languages and frameworks. Whatever it is, they're going to pull that base image to their environments, and they're going to build an application and create a Docker image off of that. They're then going to push that back to this central repository of stored images. From there, when it's time to actually run this application, whether it's in a dev, test, or prod environment, IT and dev folks are going to move that over to some cluster where you deploy the application and schedule it against the cluster, run the tests you need, or you run it in production. So that's where the build, ship, run framework comes into play. And all of this could be either running in the cloud, like AWS or Azure, or it could be running in an on-premise data center. Whether that's virtualized, something like vSphere or Hyper-V, or whether it's purely on-prem, purely bare metal, I mean to say. So that's the build, ship, and run framework. And really, you can loop back across. Maybe you build a first application, you ship it, you run it in dev cluster. Go back, do a couple more tests, and then you go ahead and do it on staging. And then you run through the process again, and eventually you're in prod. But the point is that no matter which area of the process you're in, it all looks fairly similar. So how does this correspond to the different parts of what we call our Docker Data Center solution? So that build part that I was talking about before, that's primarily based off of the open source tools with the Docker engine. That's what actually allows you to create containers and create images. The ship part, where you're storing all these images in the middle, that's Docker Trusted Registry, which is where we do secure image management and distribution. And then that run part, where you actually run the application in a cluster, that's Universal Control Plane, which is application and cluster management. And all of these operate with a series of security tools that provide things like access control, Active Directory, LDAP integration, and we'll talk more about content trust, but that's all about policy enforcement. On the bottom, this works on a number of different infrastructures, whether it's in the cloud, whether it's on-prem physical or virtualized. And on top, it integrates with a number of different ecosystem vendors, whether you're running for your images, networking, and volume plugins, or things like config management solutions like Puppet, or monitoring and logging solutions like Splunk. So that's what Docker Data Center actually is. I'm going to skip right here to the full architecture slide. So the idea here is to show you what an architecture of a highly available container solution actually looks like. So you have what we call the managers. That's the ones that actually orchestrate and define the entire cluster. And that's the Universal Control Plane managers. And these are set up and run by your IT operations admins. Those spawn off to a series of worker nodes. These are the ones that actually run your applications, whether it's in dev, test, or prod. And that's all. And so the USP managers actually run these workers. Side by side with that is what we call the image management and storage, which is the Docker Trusted Registry workers. These are all managed by the same set of managers, and these provide your image storage. And this is all highly available, which means that if any one of these nodes go down, either the applications are rescheduled or the cluster state is preserved. And then you can interact with a series of external integrations, as we talked about before, whether it's things like logging and monitoring, whether it's Active Directory for your backend, or whether it's external certificate authorities for certs. So that's a basic overview of what a highly available production deployment of containers in the enterprise looks like. So I'm going to go very quickly into depth of some of the things that you get out of this deployment. The building block of all of this is the Docker engine. And in Docker Engine 1.12, the newest version of the Docker engine, we built in a series of features that really make it easy to actually run containers in production. So we've basically created a system that offers you built-in orchestration. So the built-in ability to network a series of nodes and deploy containers against those nodes. The idea here is this shouldn't be complicated. You should be able to type in one command and create a cluster very simply, which is in fact exactly what this does. Type in Docker swarm init on the command line, and you can create a group of nodes in a single cluster. It also offers ways to make it easier to actually deploy your application and manage that application. That's called declarative app services. I'm going to talk about that a little more in another slide. There's additional features around built-in container-centric networking, things like load balancing and service discovery, which I believe Madhu is going to talk about in his separate presentation, as well as built-in default security, a mutually TLS encrypted cluster to ensure that all communications are encrypted, as an example of that. I'll defer to David on some of the more specifics. And finally, it's fully extensible with a series of plugins, drivers, and an open API. So what do you get on top of the Docker engine when you include sort of some of the enterprise features in Datacenter? There's a couple of things. One is a backwards compatibility for previous ways of running containers. So we'll talk a little bit about the Docker service command for these declarative app building. But you can also backwards support all the original commands that ran in the old swarm. On top of that, for management, you have things like a point-and-click UI to manage everything from one environment. Full CLI and API support, so you can ensure that everything works well in prod. Secure access control. We have already talked about LDAP Active Directory support, but what's very important is granular RBAC. So it's not just who's running in your cluster, it's what they have the ability to access and what level of access they actually have. And we do that across all of our resources. And finally, content security policy. How do you know where your content is coming from, what's in it, is it secure, and how do you ensure that it can be promoted into a prod workflow? David will talk more about how that actually works. So the final point I want to make around this is our idea of desired application state. So one of the things that we've done in the newest version of the Docker engine is instead of saying, hey, let's say I want to run 3 instances of my application. We'll use Redis as a key value store as an example. Normally, in the past, you'd have to manage each of these 3 instances separately. Run a Docker run command 3 times, get 3 sets of applications. If one goes down, then you got to create another one. You have to manage all the linking of load balancing and service discovery. In the newest version, we've really tried to shift this mindset towards what we call application desired state or declarative API. You set a vision of how you want your application to look like, and then setting the parameters, and then the Docker engine will actually just make that happen. So instead of saying, Docker run Redis 3 times and then managing those instances, you say Docker service Redis replicas equals 3. I want 3 instances in my cluster at all times. I don't care how you do it, just make it happen. That's how the new version of the Docker engine does this. So what it ends up doing is it'll create what we call 3 tasks. It'll run that on the various nodes. If any of those containers goes down, it'll automatically take care of spinning it back up. From a networking standpoint, you can resolve all requests against the name of the Redis name or against the DNS that's appropriate to that service, and it'll make sure that it gets load balanced to various tasks. So what I'm trying to say is our goal with Docker is really to allow you to set the vision of how you want your cluster to look, how you want your applications to look, and then for the Docker engine and Docker Datacenter to take care of the rest for you. So I'll end with just describing what exactly Docker Datacenter is packaged as. I mentioned it consists of 3 components: the universal control plane to manage applications, trusted registry is the image management, and then the Docker engine that sits below all of these components. And that's what actually does the heavy lifting of creating Dockerized containers. So we offer that with a free trial. I didn't put a logo, but you can check it out on docker.com/trial, or you can see it from the front of our webpage. And then 2 flavors of support, whether you need 12x5 support or 24x7. And really, this is what we view as a way to run Docker in a production environment for the enterprise. So that's what I have so far. I'm happy to take a couple of questions before we move on to the other presentations, if anyone has any.
You talked about Docker Datacenter. You didn't talk about Swarm.
Right. So I probably should have mentioned Swarm is integrated within Docker Datacenter. So going back to this architecture, you see there's UCP manager and UCP workers. That is wrapping Swarm and providing additional functionality on top of it. So managers and workers are actually a Swarm concept. So all of this sits on top of Swarm. In fact, all of Docker Data Center sits on top of our open source software. Any other questions here?
Is Swarm also available outside of Docker Data Center?
Yes. So Swarm is included in the Docker engine. As I mentioned before, with a Docker engine, you can do what's called Docker Swarm init, which means it'll create a Swarm cluster for you. So that's something that you can do in the base Docker engine, and that's what's included here built in. What UCP offers on top of that is sort of enterprise-grade features like access control, authent integration, and so various other sort of enterprise-grade stability and security features.
In the diagram that you showed, what is not provided by Docker Data Center, like service discovery? I mean, do you have to go outside for service discovery, like with Console or etcd or Zookeeper? And I mean, are there any other services there that would be outside of Docker Data Center?
Yeah, so I can talk service discovery, and I think Madhu will talk about this a bit more in his presentation, but that actually is included within the Docker Swarm construct. So service discovery, TCP load balancing is included. In Docker Data Center, we help you set up layer 7 load, or we set up layer 7 routing for you, but not necessarily layer 7 load balancing. So there's certain subcomponents that aren't necessarily included. I can walk through specific examples. It would probably be a long list trying to figure out all of them all at once.
And then I know you didn't talk about this at all, but I'm very confused on the difference between Docker Hub, Docker Marketplace, and Docker Store.
Right. So I can walk through that. So Docker Hub and Docker Store. Docker Marketplace is one I'm not as familiar with.
Never even heard of that.
Yeah, I don't know that.
There's AWS Marketplace, which has some Docker stuff in it,
Okay.
but maybe
Docker Store is Docker Marketplace.
that could be.
Okay.
So Docker Hub, I would think about it this way. Docker Hub is the internet where you can go and download a bunch of stuff, but you cannot necessarily verify where that content is coming from or whether it's secure or not. Docker Store is it's more of a walled garden. It consists of a series of verified images and applications, typically commercial images and applications that can be verified to not contain malware, that are actually what they say they are, and that can also be sold and distributed through the store. So one's a walled garden, the other is kind of the Wild West.
Okay, and then last question. How does Docker get revenue? Through running containers on Docker Hub and then sales of Docker Enterprise? Is that
Yeah, there's a couple of different areas. Docker Data Center is the primary enterprise solution. There's another solution called Docker Cloud, which is more aimed at smaller dev teams around running basic application development and image building. Docker Hub, you can buy private repos as well, which are basically repositories that are sort of hidden from the rest of the public. So there's a couple of small sources there. The enterprise workflows are a primary source of revenue for the company.
Thank you.